Hello my friend, and welcome back to the Nobushi Temple, and today we're going to do something a little bit different. Imagine this is our coordination device. Okay, now obviously this is y hat, this is x hat. Okay, it's this direction and that direction. Now imagine we got a ball, just like that. This is the origin of our coordination device, obviously. Now imagine we connect this. Imagine we connect the ball with the origin of the coordination. Let me use this to make it prettier. There you go. Now, let's just say the distance between the origin of the coordination and the ball is r. Now r is a amount, okay? It's with the unit of meters, centimeters, you know, the unit of length, right? And let's just say that this is r hat, this vector right here. Now, as you know, x hat, y hat, r hat, they're all vectors with the unit of 1 that shows us a directionality. And if the direction of r hat is always going to be at the same direction of the line that connects the origin of the coordination and the ball, we can say the vector of position is equal to the amount of r, the distance, times the vector of r hat. Pretty simple, right? Now, what is velocity? Velocity is the change of the vector of the position over time. So, basically, the derivative of position is velocity. Now let's just say this ball, you know, is changing its position from here to here. Okay, let me draw this video. Just like that. Let me remove this also. Let's put this. This length is r1. And this is the position of 1, obviously. And this is our new r hat. Now remember, r hat, x hat, y hat, z hat, whatever you want to call it, always have a unit of 1. So basically the vector of hats, they don't change the amount of it. It's only the directionality that changes, because the directionality of the position changes, vector of position. Okay, this is r hat 2. And obviously this is r hat 1. Now, if the ball is changing its position, it has a velocity, especially when it's a function of time. Well, obviously, in mechanical physics, we don't talk about objects that go with a very high speed, like I'm talking about speed of light, because that just changes the time speed. We cannot use that for that, but in here, velocity is the derivative of position. And believe it or not, the derivative of position is the derivative of this, which is the derivative of the first one times this plus the second one times that. So let's just write it. R dot, we use the dot for the derivative. R hat plus R hat dot. Let me make it a bit prettier. Okay. Now this part is very obvious, but what about this part? Now this part, you need to use some logic. I give you the logic behind it. Imagine in a very small time, obviously the position of the ball changes, and since it's a small amount of time, the amount of the distance is also very small. Let's call this this is position 1, okay, and this is position 2. For example, this angle is delta theta. Now this obviously is gonna be theta hat 1. Remember, the theta hat vector is always creates a 90-degree angle with the r hat. That's what we call the theta hat angle. This is theta hat 2 because since we need a 90-degree angle, we just put it like this. Okay, this is 90 degrees. This is 90 degrees too, or pi divided by 2 radius. You can say that too. Let me remove this bit here. Now, the difference between these two different vectors, the minus of them, is this. Let's just say this is the directionality of 1, this is the directionality of 2. Would be to connect these two vectors together, okay, at this direction, right? So this is r hat 2 minus r hat 1. And as you can see, if the angle of these two vectors is very small, we can kind of say the difference between them, which is this vector right here, it's the length of it, the amount of it is almost as the same as we create a very small part of a circle with the radius of 1. Okay, so this is our radius, like obviously the amount of this is 1, the amount of this is also 1. So like it's kind of like, let me remove this for you. It's kind of like a very small part of the circle. This is our circle, for example. Now visually, you can realize the smaller the angle becomes, okay, this part of the circle is almost as the same as the vector of r hat 2 minus r hat 1. So what is this length? In geometry, we know, if we got a circle, it's a very small part of the circle, that would be delta theta times our radius, which is the unit of 1. Now this length is almost as the same as r hat 2 minus r hat 1. So if r hat 2 minus r hat 1, the difference between these two vectors, the amount of it is delta theta. Also, the directionality of this, let me show you how do you show it. The directionality of this vector, this is r hat 2 minus r hat 1, is this direction. Also, this is the direction of theta hat 2. You can see they have the same direction, right? So when you go like this, right, you can visually realize r hat 2 minus r hat 1, the difference between these two vectors always is the direction of theta hat. So you go from here to here, right? It gives you this, and it's always this direction. So we can visually realize that r hat dot, which is the limit of r hat, let's just call it r hat, plus dr hat minus r hat delta theta, delta t, as delta t approaches to 0 is equal to, now the amount of this, because remember guys, the derivative of something is the change of that over time. So this vector is delta theta, the amount of it is delta theta. Let's divide it by delta t, and the direction of that is theta hat. Let me show you right here. See that? They have the same directionality. And remember, this is not a proof. I just want you to give you a vision. You know, they have proofs, you know, with very complicated math. So we're using vision to understand this. Theta hat. So therefore, r hat dot is delta theta divided by delta t, which is theta dot theta hat. So let's use this in our equation now. Let's remove this. Okay, so velocity, let me write it here. R hat dot is equal to theta dot theta hat. Simple as that. The vector of velocity is equal to r dot r hat plus r theta dot theta hat. Just like that. Now, the vector of acceleration is the change of the vector of velocity over a period of time. So, if we want to calculate the acceleration, we got to get the derivative of velocity. basically. Same. Now, this is equal to, we gotta first take the first derivative, and then you put this down, and then you take the second derivative, and you keep going. So that would be r double dot r hat plus r dot r hat dot, let me make it a bit nicer. R dot r hat dot plus, now we got to take the derivative of this. This is going to give us three equations. R dot theta dot theta hat plus r theta double dot theta hat plus r theta dot theta hat dot. This is our equation. Now we know the r hat dot is basically theta dot theta hat, so let me just write it here. A is equal to r double dot r hat plus r dot theta dot theta hat plus r dot theta dot theta. What the fuck was that? Okay, let's just remove this. So annoying, dude. Okay. R dot theta dot theta hat plus r theta double dot plus r theta dot theta hat dot. There you have it, just like that. Now, what is theta hat dot? We're gonna talk about this. Now, this is theta hat 1, this is theta hat 1 again, this is theta hat 2. This is basically that what you shifted up. Now question here, what is the amount of that? This is delta theta, okay, with basic geometry, this is also delta theta. This is delta theta prime, which you sum it with delta theta, it gives you a 90-degree angle. So this also, if you sum it with delta theta prime, gonna give you a 90-degree angle. So this is delta theta. It's basic geometry, basically. Don't worry if you don't know it, just know it's delta theta. You can use it by vision too, like imagine this, right? When this approaches to 0, okay, the alpha between this and that also approaches to 0, right? This is the vision. You didn't have to cut me off like that. We were nothing. So what is this vector that I just created? This. Let me shift this here. Is the same thing as that. This is theta 2 minus theta 1. You see the direction of this? This is r hat 2, and this is r hat 1. So you can notice if delta theta is very small, okay, the direction of r hat 1 and r hat 2 is almost the same. So we can almost cancel it out that say, okay, this is r hat and this is r2, they almost have the same direction. So this direction is almost the same as this direction. This direction is almost the same as this direction. But obviously we're making it big so you can see, so you can realize it's the difference between them, but like in very small angles you cannot. So what is the direction of this? The theta 2 theta hat 2 minus theta hat 1. Well, it's negative r hat, right? This is the r hat, and this is going this way. So instead of going up like this, it's going down like this. So it's a negative part of the r hat. What is the amount of it? Theta hat unit amount is unit of 1. So we can make a very clean circle, part of the circle, okay? This amount, it's almost the same as this amount when the angle is very small. This is the unit of 1, this is also the unit of 1. This is delta theta. God, why is this mouse so slow? This length would be delta theta, so that length also would be delta theta. So you realize theta hat 2 minus theta hat 1 is negative r hat delta theta. Now if we divide that by delta t, a very small delta t, we get the derivative of theta hat. So let's do that. And this gives us negative theta hat r hat. Get it? Oh yeah, that was fun. So let's clean this up. Let's see what we can do with our equation. Gotta be careful not to break anything. Okay. Let's write it right here. Theta hat dot is equal to negative r hat theta dots. So with this we can use in our equation. Okay, now let me make stuff a little bit prettier. Remember guys, v dot is acceleration. R dot, the vector of R dot, is velocity. Just remember that. We're just gonna make this a little bit pretty. Okay. V dot, the vector of R, double dot. There we go, just like that. Pretty nice, pretty clean with it. Okay, now let's use this in our equation. The vector of acceleration is, now I'm gonna make these things a little bit simpler. You see this? You see these two? R dot theta hat, R dot theta hat. So let's factor a theta hat here. Two R dots theta dots. We're basically using this and that. We're summing them up, right? Now, what else do we got here? This also has a theta hat. Okay, let me clean this up so we can go a bit cleaner. Okay, this has a theta hat, and this is R theta dot theta hat. There you go. Now we got another theta hat, so let's write it. I'm gonna use red on this one. Plus R theta double dots. So this is our acceleration in the direction of theta hat. What about the R hat? Because we got the R hat, which is the direction of the line that connects the origin of the coordination and the ball. This is R hat, and the 90 degrees of it is theta hat. So we got R hat directionality and we got theta hat directionality. Now, let me tell you this. This, by the equation we know, which is right here, theta hat dot is negative R hat theta dot is equal to, let's use the color green, why not? R theta dot times negative R hat theta dot. R hat theta dot, which is equals negative R theta hat squared R hat, just like that. Now, we know the direction of this is R hat basically. So I'm going to write this. Okay, I'm gonna use this and then that. Wait a second. What am I doing? Okay. We got this, and then we got that. Let's use them. Yes, let's use all of them. So, plus r hat r double dots minus r. If you do not get your face out of my fucking face, okay. I'm done. No, I'm not even kidding. I'm done. Okay, so let's clean this up. Alright, minus r hat theta dot squared. There you go, ladies and gentlemen. So the vector of acceleration is theta hat times 2r dot theta dot plus r theta double dot plus the directionality of r hat times r double dot minus r theta dot squared, which comes from r double dot r hat plus r dot theta hat plus r dot theta hat plus r theta double dot theta hat plus r theta dot theta hat dot, which is negative r theta hat squared r hat. Forget the hat here, there we go. Now we got this. Let's make it normal. Okay, that's beautiful. Yeah, I'm proud of this.